what's going on here? And now that we discuss polynomials, we understand how to divide, how to factor polynomials, how to solve equations. Then we're going to look at rational expressions, okay? And, let's go ahead and let's define this. So what do we mean by a rational expression? It's actually something that looks like a fraction. But now the top and bottom are going to be polynomials, okay? Not just numbers, but they could be polynomials. So the rational expression is an expression of the form, I'm going to call it r of x. So let's say p over q, where p and q are polynomials. Let me write properly. Where p of x and q of x are polynomials. And then, of course, the one in the bottom cannot be zero. It cannot be the zero polynomial, otherwise that doesn't make sense, okay? So that's what a rational expression is. It's just something that visually looks like a fraction, but now the top and the bottom are polynomials, okay? There is no radical involved, nothing weird going on, just polynomials in the top, polynomials in the bottom. In particular, rational numbers are rational expressions, because remember, numbers are polynomials, okay? All right, so because now there are variables involved, we need to be a little bit careful, because remember, when you have an expression, you like to plug in values, you like to evaluate the variable at some points, okay, at some values. And when you have a fraction, you have to make sure that whatever you do, you don't make the denominator equal to zero, because then division is not defined. So the values that make the denominator equal to zero, they are called the restrictions of the rational expression, okay? So let me write that down. So the restrictions of the rational expressions are the values of x for which the denominator equals zero, okay? So values of x, and let me say, i.e. the values that make the denominator zero. All right, so just keep in mind that when you're looking at a rational expression, you need to understand that that expression makes sense as long as the variable x, or whatever the letter is for the variable, is not one that will make the denominator equal to zero, because then, it's undefined. Okay, are there any questions on what a rational expression is? Well, let me just show you some. So here are some examples, okay? Again, they look like fractions in which the top and bottom, they are both polynomials, okay? And here are some of them. And as I mentioned, the regular fractions that you are familiar with, they are also rational expressions because they are a quotient of two numbers, but numbers are polynomials of degree zero, okay? So this is just a generalization of what you already know about regular fractions. All right, so now that we have defined this type of objects, as usual in math, what do we do? Once you have something, you like to do arithmetic on it. So you want to add, subtract, multiply, divide, simplify, and run that business, okay? Same thing that you do with numbers. So that's what we're going to discuss now. How do we perform these arithmetic operations on algebraic expressions? So the first thing that we will discuss is how to simplify. So today we're going to talk about simplification, multiplication, and division. And then on Thursday, I will do addition, subtraction, okay? And that's what I want you to know for the exam. Then once we come back from the exam, we're going to talk about equations involving rational expressions, okay? But that will be after the exam. All right, so let's talk about simplification first. And how do we simplify rational expressions? Well, the same way that we simplify fractions. So let me actually do the fraction example before I explain this. So let's say, imagine that we wanted to simplify this. So what does it mean to simplify a fraction? What do? We try to look for common factors, right? Between the top and the bottom. And there's something common you can cancel because when you divide a number by itself, that's equal to 1. So for example, 27 is 3 times 9. 15 is 3 times 5. Yes? Yeah. Now you can see that they both have 3 as a common factor. So we can cancel it. And then we have 9 over 5 left over. We cannot cancel anymore because 9 only has 3's in it. It's 3 times 3, and 5 is just 5. Okay? So there is nothing else to simplify. So this same idea that I use here for numbers, we do it for the more general rational expressions. So what do? We factor everything. We factor the top, we factor the bottom, as we did here, and then any factor that show up on top and bottom that are the same, we simplify. Okay? Just what we did with numbers. So let me write that down. So to simplify rational expressions, we factor the top and bottom completely, and then we simplify any factors that appear in both. Okay, so if you have something that appears in the top and also appears in the bottom, it's okay to cancel. Okay, as factors, you have to make sure that everything is factored. Okay, so that's very important. Now, there is one little rule that you need to understand, and it's this little remark that I'm saying here. For example, if let's say that you have an expression of the form a minus b, and then that same expression shows up down here. Okay, so in this case, because the top is identically the same as the bottom, as you know, when you divide the same thing by itself, what do you get? You always get 1. So this is always equal to 1. Everybody okay with this? Now, what if the top is a minus b, but let's make the bottom b minus a? Okay? Instead of being a minus b again, the same thing. What happens if I flip what's on top and I put it in the bottom as b minus a? What is that equal to? So, for example, an example here would be x minus 5 over 5 minus x. Right? Imagine that you encounter something like this. Can we simplify this? And if we can, what does it equal to? That's the general property that I'm trying to illustrate here. So let's see. So maybe let's look at the concrete example. What do you think? Can we simplify that? Let's see. Let's play. Let's pick x equals 0. If you put x equals 0, what's the top equal to? Negative 5. Yes? Put x equals 0. The bottom, what is it equal to? 5. So what's negative 5 divided by 5? 0. Oh, wait, divided by 1. Negative 1. Okay, now let's pick x equal 1. What happens in the top? What do we get? Negative 4. Everybody see that? What happens in the bottom? 4. So what's negative 4 divided by 4? Negative 1. Okay, let's do this one more time. Let's pick x equal 10. I put 10 here. What do we get on top? What do we get in the bottom? What's 5 divided by negative 5? Negative 1. So what's happening so far? So far we have been negative 1. We have been getting negative 1 without any change, right? So if anything, we could say if this is going to be equal to something, it better be equal to negative 1, right? If we're going to make this x disappear, we're hoping that it will be negative 1. So can we convince ourselves of that? Well, the answer is yes. Look, I can do a little trick. I'm going to keep the top as it is. But then the bottom, I'm going to factor out a negative. What happens if I factor out a negative in the bottom? If I take out a negative, what happens here? What happens when you factor a negative? You change the sign, right? So this becomes negative 5 plus x. Do you understand this? But now negative 5 plus x is the same thing as x minus 5. So we can write this as this, x minus 5 divided by negative x minus 5. Okay? But remember, if you have negative 2 plus 3, that's the same thing as 3 minus 2. Okay? Because addition, you can switch things. All right, and now we do know what happens here. What's x minus 5 divided by x minus 5? That's equal to 1. But now we have a negative, right? So this will always be negative 1. The negative is coming from here. Do you understand this? Well, that's a general rule. This is always the case. It doesn't have to be x minus 5. It can be whatever. The point is that anytime that you have an expression that's a subtraction on top, and in the bottom you have the same thing but flip. That will always, you can always simplify that, and you will simplify to -1. You understand this? That's what this is saying. So if they're exactly the same, it will be 1, of course. But if the difference is that the one, they are being flipped, you have one version, and in the bottom you have the flip version. Okay, then you can simplify, but you get -1 because of the flipping. Does that make sense? Keep that in mind, because you need to have that rule in mind when you are simplifying expressions. Whenever you come across a situation like this, with addition, it's okay because a plus b is the same thing as b plus a. So if you have a plus b over b plus a, this is just 1, right? Because they are the same. With subtraction, that's only when you need to be careful. Okay, so having made that distinction, then let's go ahead and let's do some examples. Again, when you're given a rational expression, if you want to simplify, the first step is to factor everything. Okay? Factor the top, factor the bottom, and then take a look at it. Whatever is common, you cancel it. If not, try to see stuff like this show up. Okay? All right, so let's see. Let's do this. So to simplify this one, the first thing that we need to do is factor everything. Now, this question is asking for 2 things. It's asking to find the restrictions and then to simplify. So to find the restrictions, it's easier if you factor everything first. So let's do that. Okay? So first step, let's factor. The top. Who can tell me how do we factor this? If we can factor. What do we need to look for? So we have been doing this for 2 weeks now. What do we need to look for? Yeah, but there's no common factor here, right? So the last number doesn't have an x, right? And among the numbers, the first one has a 1. So 1, 3, 28, there's no common factor there. So what do we need to look for? The AC method is when you have a number in front of x squared other than 1. We don't have it. This is the easy case. So what do we do in the easy case? Good. What are they? So think about the numbers that will give you 28. That when you multiply, give you -28. 7 and 4. So 7 and 4. Now we want one of them to be negative. Which one should be? So first of all, think. Can you get a 3 by adding 7 and 4? When I say adding, also think about subtracting. Okay, adding, subtracting, because one of them will be negative anyways. Can you get to 3 with 7 and 4? Yes. Now let's put the sign in the correct place. One of them must be negative because the product has to be -28, right? So which one should be the negative? The 4, because if you make 7 the negative, when you add, you get -3, but you want +3. Yes? So we do 7, -4. So that would be x minus 7, then x plus 7, x minus 4. Yes? 2 numbers whose product is -28 and the sum is 3. So found. Good. The bottom, what can we do? We can take out 2, right? Common factor. So if we factor out 2, what do we get? X plus 7. X plus 7. Good. Now, before simplifying, let's answer the first question. Now we factor everything completely, okay? Before simplifying, let's answer the first question. Let's find the restrictions. Remember, restrictions is for the original expression. So all I did was factor, so I didn't change my problem. But now, like this, is easier to find the restrictions. Remember, restrictions is whatever makes the denominator equal to 0. So to find the restrictions, let me do the restrictions. So to find the restrictions, we need to solve an equation. What equation? The bottom equal to 0. In this case, I'm going to use the factor version. Just because once you have a factor, we can immediately apply the 0 product rule. Okay? We can do it immediately. Remember, restrictions are the values of the variable that make the denominator equal to 0. Okay? We define that up here. Q represents the denominator, and the restrictions are the values that solve this equation. Okay? So that's why you take this bottom and you set it equal to 0 to find. These are the values that x cannot be. Okay? Because if you plug that in here, it makes it 0, and then this doesn't make sense. Okay? Because you cannot divide by 0. In college algebra, you're gonna call this the domain. You're gonna call this a function. This will be called a rational function for you in college algebra. And then what we're finding here is really the domain of that function, which are the values that you need to exclude. And domain is everything that's good for it. So all real numbers except whatever we're about to find out. All right. Anyways, what's the restrictions? What's the solution here? -7, right? Because if this is equal to 0, then it means this only makes sense as long as this is 0, which then give you -7. Yes? X plus 7 equals 0 means x is equal to -7. So by restriction here, what we mean here is that for the function, okay, the solution is -7, but the restriction we write it as x cannot be -7. Okay? So then my restriction is x different than -7. And you will see why we're doing that. Okay? In other words, this expression makes sense as long as x is not a -7. Because if you put -7, you're in trouble in the bottom. All right, so we have a restriction. Now let's finish the problem. Let's simplify. We already have it factored. As you can see, if you factor, you can just look at it and see what the restriction is. Okay? It's very easy once you factor. Now, to simplify, we need to see if we have anything in common between the top and the bottom. Do you see something in common between top and bottom?
Yeah.
What is it?
X plus 7.
So we see an x plus 7 showing up on both places. All right, so we can just get rid of that. Okay, and then we write x minus 4 over 2. You just write down whatever is left. Now, I want you to understand. I wrote an equal sign here. Okay, now, technically speaking, these two expressions are not equal. Why are they not equal? Well, this expression doesn't care if x is -7. You can put -7 here, you will get a number. You will get a value if you evaluate this at -7. You understand this? But this one cares about it because you cannot put -7. So these two things are the same as long as x is different than -7. When x is -7, the right side is defined, the left is not. So that's why whenever we write these things, we typically should be writing also the restrictions, just to understand that equality holds whenever this happens. Most of the time, people just skip this and don't write it down, but it's implicit in the problem that when we write this, we say this is equal as long as x is not whatever makes the bottom 0 over here, okay? Because technically speaking, the right is not exactly the same as the left because of this number. So, you know, it's good habit to write down the restrictions. Anyways, this is how you simplify. Just factor and cancel, okay? But before you cancel, write down the restrictions because after cancellation, you lose restrictions, as you can see. Every time that you cancel something in the bottom, you're losing a restriction. So you're not going to be able to see it all over here. You have to do it with the original problem. So find them before you simplify. Okay. Any questions? Yes.
Couldn't the answer be x minus 2, like if you divide the -4 by 2?
No. So to divide, remember you have to have a product. So I'm glad that you asked me this because this is a mistake that sometimes students make. So this is what your classmate is saying. Oh, couldn't you just divide this and then get x minus 2? And the answer is no. The reason is because of this. You're subtracting, you're not multiplying. You could do it if you were multiplying. So if it was like this, x times 4 over 2, then yes, okay. You can simplify, and then you will get 2x. Okay? And let's see this carefully. So for example, imagine that you could do that. So let's say they say, oh, why not? Let's do it. Okay, let's argue then that there's no way this is going to happen. And we can easily test that by picking values for x, okay? If these two things are to be the same, no matter what x I put on the left, I have to get the same x on the right, yes? For example, let's see, let's try. No matter what, sometimes it works, sometimes it doesn't. For example, here if I pick x equals 0, notice that it's gonna work. And if you stay with that, then you say, whoa, what is he talking about? If you put x equals 0, what do we get on the left? We get 0 minus 4 over 2, right? What is that? That's -4 over 2, which is -2. We put it on the right, what do we get? 0 minus 2, which is -2. Okay, here it works. Well, let's pick another one. For example, let's pick x equals 1. So with 0 works, okay? Now what if I pick x equal to 1? You're gonna have here 1 minus 4, and here you get 1 minus 2. Now what is 1 minus 4? 1 minus 4? Negative 3. And negative 3 over 2, it's negative 3 over 2. If you want, we can write it as negative 1.5. Okay? Now, if you put a 1 on the right side, what's 1 minus 2? Negative 1. And hopefully you agree that negative 1 is not the same as negative 1.5, right? Things are different. So, more of the story. So, if these two things have to be the same, they have to be the same no matter what x is. Okay? That's the point. And it turns out that they are not, right? So, in other words, you cannot just simplify this guy without. Okay? And that's the. So, the rule to be able to cancel when you have a fraction is that you need to have products. If you don't have products, you cannot simplify. Okay? You can only simplify factors. And this is a term, that's not a factor, that's a term. Okay, so again, I'm glad that you asked that because that's a very common mistake. I even see calculus students making mistakes like this. And that's a problem. So no, there's nothing more than we can do here. We just leave it like that, okay? All right, questions? Okay, let's see, let's take a look at number 2. So notice that in number 2, everything is already defined. It's already factored. Okay. Well, if you want, okay, let's factor the numbers. The 9 is I'm going to leave it like that, just because 18 happens to be 9 times 2. Okay. All right. So now that we have it like this, then before I simplify, let's write down our restrictions. So what are the restrictions here? In other words, there are two variables now, A and B. Restrictions are the values that the variables cannot be. So what are the restrictions here? So what value A cannot be, what value B cannot be? So whatever makes the bottom 0, right? And what will make that 0? That's a problem. The bottom, focus on the bottom. So for restrictions, you have to look at the denominator. What would make this equal to 0? Just use 0 product rule. This is very straightforward. So you have, I'm gonna write 18. So you have this equals 0, right? 0 product rule. The 18 doesn't matter because that's not 0, so that means either this factor is 0 or this one is 0. Yes? But if a to the 8 is 0, that means a must be 0. So restrictions are A cannot be 0, B cannot be 0, right? Those are the only values that will make this product equal to 0. So that is A cannot be 0 and B cannot be 0. So whatever we do, you need to understand that the values of A and B, they cannot be 0, okay? Otherwise, the expression doesn't make sense. Now we are ready to simplify. Okay, so certainly the 9s we can cancel, right? Because that's the same factor showing up. Now, remember the rule. We did this when we're dividing monomials. So in this case, we have a to the 5, and down here we have a to the 8. What do we do in that case? We subtract the exponents, right? So this guy is going in the top, and then in the bottom, this 8 turns into a 3. Yes? So let me write down what's left so far. So far we have a 2 in the bottom and an 8 cube, okay? And now let's see what happens with the b. So we have a b in the bottom, a b cube on top. So that means this b, we cancel it with this one, but this 3 now reduces to a 2, right? Just take out 1b. So we have a b squared left on top. And that's it. There's nothing more than we can simplify here. Again, this equality here makes sense as long as A and B are both different than 0. Notice that here we still have the restriction that A cannot be 0, but we lost the restriction for B. B could be 0 as far as the right part is concerned, okay? Because there's no B down here. But we need to remember that there was a B in the original problem, so B cannot be 0. If we want to think of this expression as a reduced version of this one, okay? That's why restrictions are important. But it's typically a pain to keep on saying restriction, so we just don't say it, but it's understood that you have to think about them when you do something with this expression, Okay. Again, college algebra, this will be brought to life once again. Okay, any questions? Do you understand this? All right, so let's see, number 3. So what's going on here? The first thing that we need to do is, what's the first thing? You factor everything, right? Okay, you factor the top together, and then I'm gonna let you factor the bottom. What's going on in the top? What expression do we have here? That's a difference of cubes. Very good. So we need to use a special formula for this, okay? If you don't remember, let me remind you of this. So recall a cubed minus b cubed. The formula for this is a minus b, and then a squared plus ab plus b squared. You have all of these formulas. Make little flashcards and learn them, memorize them. Okay? Same way that you memorize half a book of biology for one exam, you just need to memorize 4 or 5 formulas now for this exam. So make sure that you do it. Okay? Just make little flashcards, and practice. All right. So that's a formula for difference of cubes. So now we just need to know what's our a and what is our b in the problem. So what's a in this case? P. And what is b? Is 3. So you understand this? 27 is 3 cubed. Yes? So you can think of this as, okay, I'm gonna write an extra step here. Okay? You can think of it as p cubed minus 3 cubed. Again, this step is not really necessary, but typically you do that in your mind. So now, in the formula I have below, wherever I see an A, I'm gonna put a P. Wherever I see a B, I'm gonna put a 3. Okay? So this would be P minus 3, then P squared plus 3P plus 9. Do you understand this? Just replace, instead of an A, you put a P. Instead of a B, you put a 3. That's all. Okay? All right, now the bottom. What is that?
That's in
P squared minus 6P plus 9. So what do we need to do? Okay. How? What do we need to look for?
number that multiplied gives you number 9, then when you add them, when you add them, gives you -6.
Okay. What are these numbers?
-3.
-3 and -3, right? So this would be P minus 3 times P minus 3. You could write P minus 3 squared if you want. This happens to be also a perfect square trinomial. Okay? But I'm going to write it like this so it's easy to see the cancellation. Okay? P minus 3 times P minus 3. Now, before we go ahead and simplify, let's write down our restrictions. Let's see. Hopefully, we can now say it without having to solve anything. What's the restriction here? 3. What do you mean by 3? P cannot be 3. Right? Good. So P cannot be 3. That's a restriction. Again, just look at it. What makes this bottom equal to 0? P equals 3. Right? Does that make sense? Okay, now that we have the restriction in place, then we can simplify. Is there anything that we can cancel here? The P minus 3. So we cancel this guy with one of the P minus 3's in the bottom. It cannot be 5. So when you use this formula, what you get here is prime. So you can try, you're not going to be able to. I think about it. 2 numbers, the product is 9 and the sum is 3. You're not going to find it. Okay? So once you use this formula, the formula for difference of cubes or sum of cubes, this trinomial that you get here is prime. So you won't be able to seem to factor it more. All right, so we get P squared plus 3P plus 9 over P minus 3, and that's it. This is as far as we go for simplification.
On the test, you can ask us for the restriction and the.
If it asks you for the restrictions, you need to write it down. But typically, we just say simplify, and you simplify. Again, you want to see how it will look on the test, look at the review. In the review, the questions that you see in the review, those are exactly the type of questions that you're going to have on the test. With different values, of course, but the same type of question. All right. But again, you need to be aware of this. Right now, I'm not gonna be specifying this too much, but like I said, next semester, it will be a big deal, okay? Because that's the domain of this type of expression when you look at these functions. Everything except your restrictions. Okay, are you okay with this? How about 4, quickly? What's the answer here? Good. Notice that this has the parent, it's a difference, and then the bottom is the same but flipped, right? What did we say at the beginning? That when this happens, this is -1. Okay? If you don't remember that, then what you need to do is factor out a negative. For example, let's say that you didn't remember this, so you can just do the long way, which would be, oh, okay. You can actually flip a subtraction by factoring a negative. I'm gonna take out a negative in the top, and then that 2 minus x becomes x minus 2. Notice that when you distribute, this becomes -x plus 2, which is the same as this. Does everybody agree with this? -x plus 2 is the same thing as 2 minus x. And so when you cancel, you need to remember that it's a negative now. So that's how we get our -1. Okay? But it's faster if you just remember that when the same thing shows up, but one of them is flipped with a minus, then you can cancel still, but you get -1. So let's see, you do number 5. That bottom is, so this is 20 minus 5x over x squared minus x minus 12. Oh wait, number 4, I forgot to write the restriction. What's the restriction in number 4?
2. X cannot be 2.
Remember, x cannot be 2. Okay? Because, the right side is just -1, doesn't care about x. But the left side cares about x, cannot be 2. So remember to write down restrictions for number 5 as well.
Can a restriction be 2 numbers?
Yeah, of course, anything that x cannot be, you just list the separated by comma. X cannot be this value, comma, or this value. Okay, anybody has an answer? What? Let's see. What do we get when we factor the top? What do we get in the top?
2
Say that again. I didn't understand what you said.
2 parentheses x minus 10.
2. What is it? Why 2? That's a 5 or we have in front of x. Remember, common factor. What's a common factor in the top? 5. Yes? So if we take out 5, what do we have in parentheses?
4 minus x.
4 minus x. So remember, 5 has no 2's in there. Okay? Yeah, okay. So you could do -5 as well. If you do -5, then you will get x minus 4, which would be convenient. But that's okay because we have the other rule. So it probably would be easier to do -5. But let me leave it like this. That's the way I get to use the rule from the top. But yes, you could do -5 and then get x minus 4 directly. The reason for that is because of what is about to happen now. So how do we factor the bottom?
X plus 4. X minus 3.
So what do we need? What are we looking for?
Looking for what could equal -1 and what could be multiplied to -12.
Okay, so two numbers whose product, always focus on the product first. The product is -12 and the sum is -1. What are these two numbers?
4 and -3.
Did you do positive 4 and -3? What's the sum?
Oh, sorry, -4.
So remember, you have to check two conditions, okay? The product, okay, one's 4 and 3, one of them negative. But now you need the sum to be negative. So that means the bigger guy has to be the negative one. Okay? Otherwise, the sum would be positive. So that's negative 4, positive 3. So that would be x minus 4, x plus 3. So if we would have factored negative 5 originally, then this would be an x minus 4, and then it would be convenient to simplify. That's not really a big deal. You can still simplify here, but you need to remember, it doesn't just disappear. You will get a negative 1 as a result because of the rule. Remember that? So that's the only thing you have to keep in mind. But before we get to do that, let's write down the restrictions. What are the restrictions? So x cannot be 4 and cannot be negative 3. Does everybody understand this? The 4 is coming from the first parenthesis, and the negative 3 is coming from the second parenthesis. Okay? These are the only values that we made this bottom equal to 0. So we say, okay, as long as x is none of these two guys, that expression makes sense. All right, now we simplify. Now we can do this, even though they are not exactly the same, but you need to understand that we get a negative 1 as a result, okay? So then we get negative 5 over x plus 3. Now, when it comes to a negative and a fraction, you can put the negative wherever you want. You can put it in the top, you can put it in the bottom, or you can put it in the middle. When this happens, we like to write the negative in front. But it's okay if you leave it in the top, okay? If you're gonna put it in the bottom, that's fine, but then you need to put parentheses. Okay? Because it has to affect the entire denominator. So these three expressions are exactly the same. Typically, we like to put the negative in front, okay? Or we do the one on the left. We don't like to do this because we don't like to see parentheses in a simplified version, okay? There should not be parentheses. So I'm gonna get rid of it, but understand that they are equal, okay? So once again, these two expressions are equal as long as x is none of these two values. Why? Notice that here we still remember the restrictions of negative 3 because this one is not okay for negative 3. But this one is fine with 4. You can plug in 4 here and you get an answer. You're gonna get negative 5 over 7. But 4 is not good over here, okay? That's why I insist we need to write the restriction before you simplify. Are you okay with this? So again, just let me put it here. If instead of factoring out 5, because let's say that you would have done the bottom first, and you realize that this is factors like this, then you see that if you take out 5, you're going to get a 4 minus x. You could get ahead and say, okay, I'm going to factor out negative 5 instead. And as you know, what that does for you is it flips it, okay? So you will get your x minus 4. And that way you don't have to work with that little rule that when they are flipped, you can answer, but you need to remember there's a negative 1, okay? And then you get the same answer, of course. Okay, questions about simplifying rational expressions. So notice that this is very straightforward as long as, what's the required skill that you need here? What skill do you need to be able to do this? Factoring. As long as you can factor, this will be easy. If you cannot factor, it's going to be hard because you need to factor to be able to do this. Okay? So if factoring is already a given, then it should be okay simplifying rational expressions. So now that we know this, let's talk about multiplication and division. Multiplication and division is equally easier. If you know how to simplify, then you can easily multiply and divide. Okay? Addition and subtraction is the one that requires more work. We're going to talk about that on Thursday. Okay? But at least with this, we can immediately do multiplication and division. You just need to remember the rule of how we multiply and divide, and then it's just a matter of simplifying, as you're about to see. So how do we multiply and divide rational expressions? Here is the rule, the same way that we do with fractions. So when you multiply, you do what we expect. Top with top and bottom with bottom. So this would be A times C over B times D. You multiply the top with the top and the bottom with the bottom, and then you simplify. Okay, because when you do this, you're going to obtain one fraction, okay, one rational expression. Now you simplify it, as we have been doing before. And division is exactly the same idea. It's just that we need to do an extra step at the beginning. the rule for division is it turns into a product and you have to flip the second fraction. Okay? So the first one stays the same. Division turns into a product, but you have to flip the second fraction. Okay? That's all. We already discussed how to multiply. You do top with top and bottom with bottom. And then simplify. All right? Any questions? Do you understand this? Yes or no? All right, so let's do examples. Again, the multiplication is just top with top, bottom with bottom. That's all you do. And division is the same idea, but first you have to turn it into a product and flip the second. Okay? All right. My advice to you is before you do anything, factor as much as you can. Okay? So before you actually do the rule, just factor everything, and then you carry out what you need. Okay? So that's the first thing that I'm going to do. I'm going to go ahead and factor out everything. Let's see. We have 4 polynomials to factor now. Okay? Let's worry about the first one. So we need 2 numbers whose product is 16 and the sum is 8. The numbers are 4 and 4, right? So this is x plus 4 times x plus 4. So I'm going to write it as x plus 4 squared. Okay? The bottom is clear that the common factor is a 10. So we get 10 times x plus 1. Let's go to the next one and repeat. In the top, we can take common factor 2 and we get x plus 3. Now in the bottom, we need 2 numbers whose product is 12 and the sum is 7. Those are 4 and 3, right? So that's x plus 4, x plus 3. Now, just like, okay, let me just follow it. Now that everything is factored, I'm going to use a rule which says multiply the top with top, bottom with bottom. That just means put everything in the top together and everything in the bottom together as factors, okay? So that would be x plus 4 squared times 2 times x plus 3, and then 10 x plus 1 times x plus 4 times x plus 3. I literally follow the rule. Just put the top with the top and the bottom with the bottom. That's all. But now we simplify. Now the good thing is that we already did the factoring at the beginning, so we don't need to factor anything. Now it's just a matter of seeing what can be cancelled and what cannot. Okay? So let's see. What appears in the top that's also in the bottom?
X plus 3.
So there's an x plus 3 here, there's an x plus 3 here, right? So we can get rid of it. Let's see, can we do something about that number 2? Can we simplify with something in the bottom?
10.
There's a 10 in the bottom, right? 10 is 2 times 5. So if you want, everybody knows 10 is 2 times 5, right? So it's 2, cancel with the 10, give me a 5 left over down here, okay? Anything else that we could simplify? At the x plus 4, there is 1 x plus 4 down here, but we have 2 x plus 4s in the top, yes? So one of them cancel with this one. So I'm just gonna get rid of this power, cancel it with this one, but understand that there is 1 left over in the top, yes? We have 2 of those. Anything else that we can cancel? Let's see, the only thing that remains down here is an x plus 1. Do you see an x plus 1 up here? No, so that's it. Now we write down what's left. What's left in the top?
X plus 4
An x plus 4.
times 1.
And what's left in the bottom?
5 x plus 1
The 5
times
times x plus 1. Questions? Now, as you can see, typically what happens is that we don't really write this middle term. Because anyways, when you're multiplying, it's understood that anything that's on top on both expressions will be the top of the product, and anything that's in the bottom is the bottom of the product. So this cancellation that we did typically happens at this stage. And then we just go from here to the final answer, skipping this in between. Okay? So just to illustrate what I mean, let me rewrite this. So So typically what happens is that we cancel at this stage, just because, anyways, anything that is in the top, on any of the two expressions, will be the top of the new one, and what's in the bottom will be the bottom of the new one. So we can simplify vertically or diagonally, okay? Doesn't really matter. So for example, this x plus 3, I can cancel it with this one. This 2, I can cancel it with this 10, and this x plus 4 with one of the x plus 4 up here, okay? Because bottom, top. Do you understand this? And now when we actually carry out the product, we just write what remains, which is an x plus 4 in the top, and then in the bottom, a 5 times x plus 1. Notice that everybody from here was gone, okay? And that's typically how we do it, instead of going through this in between. But if you like to do this, you can do it. It's just an extra step, and you need to write more, okay? That's all. Okay, questions about multiplication? All right, and then let me do this division, and then there are some for you to try. Okay, so let's do this one. All right, so for multiplication, step number 1, factor everything. If you want, you can also factor everything here, but then you could then forget that this division has to be turned into a product. So you may want to do that at the very beginning, that way you don't forget. Okay? So the moment that you see division, you use the rule. Turns into a product, flip the second fraction. Okay? So we immediately do this. The first one stays the same without touching. This turns into a product, and then you flip the second fraction. Do you understand this first step? Yes? Okay, so now we do as before. Let's factor everything, and then we figure out what can be simplified. Okay? So division turns into a product, and this one flips. Okay? All right, so now let's factor. Let's see, let's go one by one. The first one. What can we do with the numerator? Numerator is the top. What can we do with the top of the first one? We can take out an x, and we get x plus 1. Yes? The bottom, what can we do?
X squared.
We can factor out an x squared. Remember, always look for common factors, okay? We can factor out an x squared, and then what do we get? 5x minus 1. Good. Now let's go to the next one. What do we have in the top? 25x squared minus 1. What can we do here? What is this? So this is a binomial. When you see something like this that has two terms, and you cannot play this game of taking a common factor like what we did here, okay? If you see two terms, then, and if you want to factor, you should be looking for either difference of squares or difference or sum of cubes. That's it. Those are the only things that can be factored when there are two terms, unless they are like this that you can do a common factor. Now here there's no common factor. Now there are no cubes in here because there is a square, right? And there's a difference, so this better be a difference of squares. How do you check? Look at the two things and see if they're perfect square. 1 is 1 square, so that's fine. And x squared is fine. How about 25? Can you write 25 as something squared? What is it? 5 squared, right? So this is a difference of squares. So let me write it here. So 25x squared minus 1. We recognize this as 5x squared minus 1 squared. Okay, that's a difference of squares. Now remember, we have a little formula. So recall. Who remember this? How do you factor difference of squares? It's the easy one.
A plus B, A minus B.
Good. A plus B, A minus B. Okay? The one with the cubes is the one that's longer, and it could be a little bit more problematic to remember, but this one should be pretty straightforward to remember. Okay? Again, just figure out what's your A, what's your B. Let's see, what's A here? A is whatever is being squared in the first term. So what's being squared in the first term? 5x. And what is B? 1. And now just with our a and our b, just put in the formula. So what is this? 5x plus 1, 5x minus 1. A plus b, a minus b. Does that make sense?
Yeah.
Okay, so we got that, so let's put it here. That's 5x plus 1, 5x minus 1. Okay, so now we need to deal with the other one. So the other one is 10x squared plus 12x plus 2. What can we do here? Before that, what's the first thing that you should always do? Common factor, right? To see, is there a common factor here? We could take out 2 at least, right? So let's do it. So it's going to be 2 times, and then we get 5x squared plus 6x plus 1. So at least we are working now with smaller numbers, okay? Better. All right, so it's gonna be 2 times this. So now our job is to factor this parentheses. So for now, I'm just gonna write my 2 here, and then let's just focus on this guy now, okay? So let's factor 5x squared plus 6x plus 1. I'm splitting this into different little steps, that way, otherwise I have to keep writing the parentheses and that's painful. So I already put the 2 here. Let's just factor this one, and whatever the result is, we write it here, okay? All right, so now here, this is a trinomial, but this time the beginning is not a 1, okay? The leading coefficient is not a 1, so we need to use AC method or trial method, whichever you want, okay? Let's stick with the AC method because I think that's the most safe for you, okay? But you do what you want. What does the AC method says? You have to look at the product, the first and the last number. 5 times 1, that's 5. So we need 2 numbers whose product is 5 and the sum is 6. What are they? 2 numbers whose product is 5 and the sum is 6, that's 5 and 1. Yes? So because 5 plus 1 is 6, what we do then is we split the middle as 5 plus 1. So instead of 6x, we write 5x plus x. Okay? First and last stay the same. And now we factor by grouping. So you group first 2 and last 2. So that would be, let me write it down here. So that would be, I can take out 5x here, and I get x plus 1, and then the other group, I don't do anything, and just keep it like that. Let me put the parentheses, because now we see the x plus 1 popping up. You can factor that. And what's left if I take out x plus 1 from here? What's left from the first one? 5x. And from the second one, just a 1. Remember this, there's a times 1 here, just that we don't write it, okay? There's a times 1. Okay, so we have the factor, x plus 1 times 5x plus 1. Let's put it here. So understand that all this, the one with 10 and so on, this is the complete factor with the 2, okay? That was the 2 that we did already. Now that everything is completely factored, it's show time. We can start canceling things. Let's see. Do you see anything on top that can be canceled with anything in the bottom? Let's go one by one. The first factor, x. Can we cancel x with somebody? Yes, there is an x in the bottom. In fact, we have 2 x's in the bottom, right? So this x is going with one of the x's in the bottom, there's 1 left over. It's always a good idea so you don't lose track of what's going on. Write down what's left, and then you organize your answer. So far, there is an x in the bottom, okay? I'm gonna put a 1 in place of the x that we removed, okay? All right, let's go to the next one. X plus 1. Can we do something with that x plus 1? There is another x plus 1 in the bottom, right? So this guy is going with this one. So they just give me 1s. 5x plus 1. Can we cancel that? Yes, this one is this one. Again, 1. The 1s are not necessary. They're just put in there so you understand that it's not like things have disappeared. They become 1. Okay. And then 5x minus 1. Can we cancel with something? Yes. This guy down here. So that's a 1. And then that's it, we have nothing more on top. So in the bottom, notice that there was a 2 that we didn't touch, so we have to write. Okay? So what's the answer? 1 over 2. All right, questions? Did you understand this? So again, the complicated part here is the factoring part, okay? So that's why I insisted, make sure that you know how to factor. Because with factoring, you can solve equations. And also, you can do these problems. Okay? So as long as you understand factoring, you should be okay. All right. Questions? All right. So give it a try. Try number 3 and number 4. Again, in number 4, this is another way that you can write division. Okay? Remember, fraction is just a division. So this is really the top divided by the bottom. Okay? This is a 3y. Let me write it. So try number 3, and then we do 4 together. So don't worry about 4 for now. Just, if you finish number 3, then do number 4. Take attendance.
3 times y minus 2.
So 3 times y minus 2. Good. Do we do anything with the bottom? No. Stays like that. Okay. Move on to the next one. How do we factor that? The top of the second one.
Y plus 1 times y plus 2.
Good. How do we factor the bottom?
2 parentheses y minus 2. I wasn't sure about that one. That's what.
So there is. Okay. Remember, if you want to look for common factor, you have to see there is no number in front of. There is a 1 in front of the y squared. So there's no common factor with 4. So you cannot factor 2. Again, that's a difference. What should you be looking for? Difference of squares or cubes, because there's no common factor. Which one is this? Squares. So what's the formula? A plus b, a minus b. So it would be y plus 2, y minus 2. Yes? Does everybody understand this? Do you recognize that as a difference of squares? 4 is a perfect square, it's 2 squared. Okay? That's it. Everything is completely factored, so now it's time to cancel things. All right? So again, just go one by one from left to right in the top, and just start canceling little by little. So let's see. The 3, can we cancel it with somebody? With 6. 6 is 2 times 3, right? So 3 cancel with the 6, and then you get 2. Do you understand this? Remember, 6 is 2 times 3, okay? All right, y minus 2, can we cancel it with something? Let me start writing down the stuff that remains.
Yeah.
So y minus 2, yes, cancels down here, right? So they have a 1 in their place. Y plus 1? No. So leave it there. Y plus 2? Yes. And then there was that y that we didn't touch. So let me write it down. So this y that I put here is this one that we didn't touch. Okay? All right, so what remains on top?
Y plus 1.
A y plus 1. And what remains in the bottom?
2y.
A 2y. Questions? Do you understand this? So remember, once you factor, what you have to do is start looking and see what from the top can be simplified with something in the bottom. Okay, that's all. The tricky part will be the part with the numbers. Then at this stage, just make sure, because typically we don't factor the numbers. If you want, you could factor the numbers. Like 3 is 3 times 1, and 6 is 2 times 3. That's the prime factorization, and then it will be more obvious to see. Okay. All right, and then let's do number 4. Are there any questions about 3? Okay, so number 4, remember that big fraction, that's just a division, okay? So this right here is the same thing as division symbol. So the first step is keep the first one as it is. Write a product instead of a division, and then flip the second one. Everybody okay with this? All right. So now we need to factor everything. Now here we have to do some AC method. So let's see. Let's do it with the first one. Do you want me to do AC method? Do you mind if I do it trial and error? Trial and error is fast. I'll do trial and error. I mean, we have done AC method already several times. Okay. So you just stick with whatever you want. In this case, I'm gonna use trial and error. So I'm gonna put 3 and 1, and then I'm gonna do 2 and 1. And remember, this is how when you cross multiply and you add, you get the middle one. So 3 times 2 is 6, plus 1, that's 7. That's exactly what I need. So that means that's 3x plus 1 times x plus 2. So these are the coefficients of the first factor, these are the coefficients of the second factor. Okay. Then in the bottom, I can take out 4, so we get x plus 6. In the second one on top, we can do 6 and negative 5. So that's x plus 6, x minus 5. And in the bottom, I'm going to do another little try and error. So I'll do 3 and 1. And then because I want to get 14, I'm going to put my 5 down here, because that way I get my 15. Now, one of these must be negative because of the negative 5, and I want a negative 14, so I'm going to put the negative down here. Because now when you cross multiply, you get negative 15 plus 1, which is negative 14. Okay? This is what we need. So that means this will be 3x plus 1 times x minus 5. Again, you do that using AC method, and eventually you're going to get here. Okay, it's just that it takes you a couple extra steps. Okay. All right. So after doing this, then we start simplifying whatever we can simplify. So, for example, this guy cancel with this one. Okay. Let me start writing. So that's a 1. Then x plus 2 doesn't cancel with anybody, so stays there. X plus 6, I can cancel it with this. And then x minus 5, I can cancel it. And then looking, I see that, okay, the top is where we're done, and the bottom, we didn't touch the 4, so I have to write. So what's the answer? What remains on top? X plus 2. What remains in the bottom? 4. Again, I know it's tempting. Don't cancel this 2 with this 4. Okay? Don't do that. It looks nice, but no, it cannot be done. Okay. All right. Questions? All right. And then just as a quick thing, these operations can be combined together. Okay. And remember the order of operations. When you have multiplication and division, you do them left to right. Okay. Whichever appears first. So I'm gonna go ahead to do this quicker and start factoring. So I'm gonna take out 4, that's x plus 1, 3. That's x minus 5. Now for the second one, that would be negative 5, positive 2. So that's x minus 5, x plus 2. This one down here, that's 8 and 4. So I need negative 8, positive 4. So that's x minus 8, x plus 4. And remember, the division turns into a product, and you have to flip it, okay? So this bottom goes to the top, this top goes to the bottom. Now I'm gonna write it factor already. I'm gonna take out 6, and that's 8 times 6 is 48. So that's x minus 8. That's the factoring of this bottom that becomes top, okay? And then the factoring of the top that becomes now the bottom, because 12 times 3 is 36. And now we can see what can be done. For example, this 4 can be cancelled with this 12, giving me a 3. This x plus 1 cannot be cancelled with anybody, so it stays there. X minus 5 is gone here. X plus 2, nobody in the bottom. The 6 I can cancel this 3 with the 6, giving me a 2. And x minus a, I can cancel. All right, so let's write down what's left. In the top, what do we have left? We have left a 2, an x plus 1, and an x plus 2. In the bottom, what do we have left? We have left a 3, an x plus 4, and an x minus 3. That's far as we go.